Welcome. We will discuss today on bioinorganic. Chapter H, bioinorganic. So in bioinorganic chapters past, the topic is porphine ring. So its structure. Its structure is it has for nitrogen. It says okay. So it has that 5 bonds. 1, 2, 3, 4, 5. Similarly here 5 bonds. Okay. And here what you do that next to this nitrogen atoms, this carbon atom, and next to this nitrogen atom, this carbon. So like that here next to nitrogen atoms. Okay, that you will dot point you will do. Okay, what to do, you will join this points here, you do 1 points, and here also you will do 1 points, here also 1 points, here also 1 points, and you just join all the points. Then the porphyrine ring will be synthesized, means drawn. Okay, like this. Right. Now what you will do here, that this all are in the conjugation, so you will start from here 5 bonds. So here one leave, this is conjugation, so I will leave one, then I will draw here, and this I will leave, then I will draw here. Okay. This I will leave here, this I will leave here, here, this I will leave here, this I will leave here, and this I will leave here, this one I will leave here, and okay, so these all are in the conjugations. Okay, and what we say that these positions are called the meso positions. These are called the meso positions. These are called the meso positions. These are called meso positions. So obviously here hydrogen atoms are there, so this is conjugation, so one hydrogen atoms is there, like this benzene ring, everybody one hydrogen atoms, these are in conjugations, and one hydrogen atoms are there. Similarly these are in all in conjugations, and here one hydrogen atoms is there, so one hydrogen atoms here again. So here in all meso positions hydrogen atoms, and here also in the beta positions also. See, this is the meso position, then this is alpha, and this is beta. Similarly this is the meso position, this is alpha, this is beta. So like this, these are the beta, these are the beta positions. Okay, so here also hydrogen atoms are there, hydrogen atoms. These are the beta hydrogen atoms. Why? Because this is the meso position, then this is alpha, and these are the beta. Similarly this is the meso position, this is alpha, and this is the beta. So these are the beta hydrogen atoms. Okay, and you see here that here the lone pair is there. Okay, so this lone pair is in conjugations, but here this lone pair is not in conjugations. So here the lone pair is in conjugations. Okay, whenever the adjacent to nitrogen atoms, if double bond is present, then lone pair is not in conjugations. So here that hydrogen atom is there, hydrogen atoms, there also hydrogen atoms. Okay, so this is the structure of porphyrine ring. Okay, this is the structure of porphyrine ring. So if you look this bonds, this ring, then what you see that how many 5 bonds are there. So if I count from here, then this is 1, this is 2, this is 3, this is 4, this is 5, this is 6, this is 7, this is 8, this is 9, this is 10, this is 11. So total number of pi bonds are 11. Okay, so if I search total number of pi bonds is equal to 11. Okay, this is the first things. And we will look that total number of meso hydrogen atoms and meso position hydrogen atoms are there. So total number of meso hydrogen atoms, how many? This is 1, this is 2, this is 3, this is 3, and this is 4. So total number of meso hydrogen atoms are 4. Now total number of beta hydrogen atoms, and another is total number of NH atoms. So you know, so the beta hydrogen atoms, what are these? Are the beta hydrogen atoms. So how many beta hydrogen atoms are there? 1, 2, 3, 4, 5, 6, 7, 8. So total number of beta hydrogen atoms are 8, and total number of NH atoms only 2, 1 and 2. So 2 total number of NH hydrogen atoms. Okay, now let's discuss more on these porphyrin rings. Okay, so these porphyrin rings, what it says that it is rigid structure. It is a rigid structure. It is a rigid cyclic structure, or you can say rigid structure means it will not change. It will not change its size. Okay, and what is say that whenever you add, we'll discuss one another points, that is metalloporphyrin ring. Okay, so what is this metalloporphyrin ring? So in this metal, in this porphyrin, in this porphyrin rings, one cavity is there. When in this cavity, if metals is attached, then that is called that metalloporphyrin ring. So in the cavity of porphyrin ring, if metal ions added it, then it is called metalloporphyrin ring. Okay, and in this cavity of the metalloporphyrin rings, but this cavity is ideal for the 3D series. Okay, so the cavity of porphyrin ring is ideal for 3D series transitions metal. Okay, so that is follows the, it is given by Irwin Williams series. What it says that first will be zinc, then zinc 2 plus, then we'll do that ferrous 2 plus, then we will go for cobalt 2 plus, then we will go for copper 2 plus, then we will go for nickel 2 plus. Okay, so this is that series that will follow the, if you are adding the metals to this cavity of porphine rings, then this cavity, this order will be followed. So this order we have to remember. Okay, and what you see that if the size of metal ions is larger or higher than cavity of porphine ring, then the metal will locate at above the ring, above or below the ring. Okay, that will not go inside the ring if the size of the metal is larger or higher than the cavity of the porphine rings. Okay, and what it says that the porphine ring is rigid and it will not change its size according to the size of metals. So the cavity of porphine ring is rigid and it does not change its size according to metal ions. So the porphine ring is selective to metal ions. So these are the some characteristics of that porphine rings, and one more that things is that it is square planar in geometry. Okay, so these are the some points on porphine rings. And now if you do the characterizations of the porphine rings, okay, or one more points we will discuss, that is, if in a porphine ring or metalloporphines, okay, so let's say if PR is there, that is porphine rings, if you add the acid, then what you will get, that certain PR ring you will get, and it is not able to add metals. So here we can't add metals. And if in the porphine ring, if you do the base, then this onion PR ring will forms, and here metal can be added. Okay, so now these are the some properties of porphine rings. Now we will discuss on characterizations. Now the characterization of porphine ring. Okay, so first we will do that NMR characterizations. So if you do the NMR characterizations, what you see here, that this structure. So I will do the NMR characterizations here itself. So NMR characterizations, if you study, then what we see that here, that meso positions, 4 hydrogens are there. 4 hydrogens are there at meso positions. So 4 hydrogen at meso positions. So here that chemical shifts, that is this value for 4 hydrogen, we will go to the 4 chemical shift value. Okay, and for beta hydrogens, how many beta hydrogens are there? 8 beta hydrogens atoms, and the chemical shift value also will get that 8. Okay, and for NH atoms, here 2, so 2 NH atoms are there. Here also the chemical shift you will get the 2. So it is very easy to remember that for chemical shift for 4 hydrogens we will get, for 4 meso hydrogens we will get chemical shift 4, and for 8 beta hydrogens we will get 8 chemical shift, and 2 NH atoms we will get 2. So why this is, you are getting this amount of chemical shift value for 4 hydrogens, so that we know that whenever this the structures, so if here hydrogens are there, here hydrogens are there, this is actually symmetric structures. But if he says that if here is hydrogen, here some other molecules are there, so whenever you see that this ring structure, so ring will be like, it will flowing like this. So whichever that, I will draw here nicely. So let's say this is the ring structures, so this magnetic field will flow here. Okay, so whichever the atoms which is lies inside or in the directions of the magnetic field, means if the hydrogen is here, then this hydrogen will be highly shielded. So if it is highly shielded, then it will get the low chemical shift values. Okay, so these hydrogen atoms are inside the rings, means whenever the magnetic field will be here, this magnetic field which is going to like this, means these are inside, so these are highly shielded, so this will get low chemical shift value. That's why this is the low chemical shift value will get. Similar, this beta hydrogen, these are the outside of the magnetic field, means here this type of atoms, these are the outside of the chemical shift, magnetic field, so they will get highly de-shielded, so high chemical shift value will get. That's why 8 beta hydrogen will get chemical shift value at 8. Similarly, for meso positions, these are also near to inside, that's why they are also little bit shielded, so its chemical shift value also little bit low. Okay, so for hydrogen atoms we will get, for 2 nitrogen atoms we will get chemical shift value at 2, and for 8 beta hydrogen atoms we will get the chemical shift value at 8. So these are the NMR characterizations. Similarly, we will go for EV visible characterizations, spectroscopic characterizations. Okay, so what you see here, this structure, whenever you go for EV visibles, then due to these pi bonds and this non-bonding electronic transition is happening, so here we will get what type of structures here, like this type of bonds we will get. Okay, so this bond is, this is due to pi to pi star electronic transition, and this is due to ND to pi star electronic transition, and these are called Soret band, and these are called Q band, and this is found nearly 400 to 450 nanometer, and this is mainly found 500 to 600 nanometer. Okay, so whenever to this is the this structures. Okay, this structure is something like this. You will get UV visual spectroscopy, this form. Now if I add metal ions to it, then what happened, this Q band, means this metal ions will do electronic transitions with non-bonding electrons, so here this Q band will be disappear, you get only these bonds. Okay, this this Q band will disappear because this metal ions will make bond with this non-bonding electrons, so this Q band will be disappear. So here what, Q band disappear. Now again, if you add, you will do something so that there will be the conjugations of this pi bond will be not there, then what you will see, that this solid bond will disappear, then only you will get this. If we add something so that conjugation disturbed, then you will get only this bond, this solid bond will be disappear. So here all are in conjugation, so if you add something so that this conjugations will disappear, then only you will get this solid bond. This is very good way to characterize this porphine rings by UV visible spectroscopy. And for IR, so IR spectroscopy very less to study for characterizations of porphine rings, because here that NH bonds are there, and NH bonds we are getting IR, that is 33,000 to 34,000 centimeter inverse, and OH also you get, sorry, NH you will get 33,000 centimeter inverse, and OH bond you are getting 33,000 to 34,000 centimeter inverse, 34,000 inverse. So whenever you are studying the IR, then what happened, some moisture will be there, so for that also OH will be there, so we will get this value also, and so that we will not get that NH spectra clearly because of some moisture will be there, so that will be also coming in the same range. So we are not used to study the IR spectroscopy for porphyrin ring, the porphine ring. Okay, now if you go for that synthesis, next topic is synthesis of porphine ring. Synthesis of porphine ring. Okay, so how will you synthesize? So first is, let's say nitrogens. Okay, here 4 plus if you do any aldehydes, and if you have BF3 with OT2, one pair is there, and DDQ, then we will get that PR ring. Okay, and here this hydrogen will be hydrogen at meso positions. Similarly, if I go for this porphine rings, here also 4, plus here if I add pH, this, then same things, BF3, DDQ, then PR ring I will get, but here pH at meso positions. So in this way we can synthesize the porphine ring. Okay, so today I will discuss only up to porphine rings. Next class we will discuss on heme proteins and non-heme proteins. So heme proteins, if I say some quick introductions about of heme proteins. So these heme proteins, so why we have studied that porphine ring? Because in heme proteins, what is it? This is PR ring plus Fe atoms. Then that is called the heme proteins. This is the porphine ring plus Fe atoms. And whenever we say that non-heme proteins, here that no PR rings, means this porphine ring will be not there. No PR ring plus Fe atom. This is called non-heme proteins. Okay, so that we will discuss in next class. Today after this, thank you.